Hello GMAT aspirants. I hope your preparation is going well. We are back with yet another episode of GMAT Friday with IMS International. Here's the question of the week. You know what to do. Pause the video, give it a shot, and then resume to look at the solution. Alright, so this is a question that combines two topics of algebra. What are they? You can see that this question is talking about inequalities, and at the same time there are some algebraic polynomials over here, right? So there are two topics, higher order algebraic polynomials as well as involving a topic of inequalities. Now before we go and attack this question, let's try and understand how do we solve these questions on inequalities, right? So let's try and understand the entire theory behind how to solve a quadratic inequality or how to solve a higher order inequality, right? Let's begin. So let's start with a very basic example. Let's say the question is x plus 3 must be greater than or equal to 0 and x is any real number. Now I think so it's very easy to understand. How do we go ahead and solve this question? What would we do? We would subtract 3 on both the sides. So what am I left with? X is greater than equal to minus 3, right? So any value on the number line that is minus 3 or more than minus 3 will be satisfying this inequality, right? So let me just plot it for you. So we have minus 3 over here. So if I take minus 3 or if I take minus 2 or if I take minus 2.5, any value to the right of minus 3 if I am taking, I am going to see that this inequality is being satisfied. So this is very simple to understand, and this is what a linear inequality, right? But what if we have two different polynomials multiplied with each other, or maybe three different polynomials, or maybe five different polynomials multiplied with each other, right? We do not have that much time of checking it like this. So there has to be a short trick, and that is what we are going to be learning next. Alright, so now let's say I have got this quadratic polynomial x plus 2 into x plus 3. This must be greater than or equal to 0. Now let me take back to another unit of algebra, that is equation, that is quadratic equation. So if I give you something like this, that x plus 2 into x plus 3 is equal to 0. If a quadratic equation is given to you, how do we solve this? We know that this is A and this is B, and if the product of two numbers A and B is equal to 0, one of them has to be 0, right? So either x plus 2 is equal to 0 or x plus 3 is equal to 0, which tells me that either x is equal to minus 2 or x is equal to minus 3. Easy peasy. I mean, this is something that we have been doing since maybe 6th or 7th standard, right? But that same logic cannot be applied to quadratic inequalities. There's a slight difference. We cannot do this, that either x plus 2 is greater than equal to 0 or x plus 3 is greater than equal to 0. This would be wrong, right? So the things that we can do in equations cannot be done in inequations, right? So that should be your learning number 1, right? Just to give one more example, let's say if I tell you that minus 3x is equal to 6, we can say that x is equal to 6 over minus 3, that is equal to minus 2. I mean, this is something that we have always learned, right? But if I tell you, for example, that 10 is greater than 6, and if I multiply minus 2 on both the sides, what do I get? Minus 20 and minus 12. Now this inequality sign won't hold true. I will have to change the direction, right? So in terms of equation, multiplying or dividing by a negative number was never a problem for us. But in an inequation, whenever we are multiplying or dividing by a negative number or a negative maybe variable, we are supposed to change the sign of inequality, right? So there are some, I would say, drastic differences between how to approach a quadratic, how to approach a equation and how to approach an inequation, right? So let's go and attack this question again. So we have got x plus 2 into x plus 3, and the product of this should be greater than equal to 0. Now, how do we solve this? So the first step would always be to draw your number line. Now, on this number line, you would be plotting the zeros. Now, what are zeros? The value of x for which any of this polynomial would be equal to 0, right? So, x plus 2 equal to 0, that means x is equal to minus 2, or x plus 3 is equal to 0, therefore x is equal to minus 3. Now, please note that you ideally should not be writing all of this. This is something that should be happening in your mind. It saves a lot of time. Alright, coming back to this. So, if x plus 2 is equal to 0, that gives me x minus 2 and x is equal to minus 3. So, I am supposed to plot both these points on this number line, right? So, minus 3 would be coming over here and minus 2 would be coming over here. Now, if you can see that just because I had drawn 2 points, my entire number line was divided into 3 regions, right? Similarly, if I would draw 4 points, my entire number line would be divided into 4 plus 1, that is 5 regions. Alright, so what you are supposed to do next is take any value in any of these ranges and check how this inequality is functioning. So for example, if I take any value to the right of minus 2, let's say I take a 0. Now I will substitute 0 over here. What do I get? 0 plus 2 is a positive number. 0 plus 3 is also a positive number. Multiplication of two positive numbers will be positive. Therefore, any value to the right of minus 2 will always yield a positive value in this particular expression. Next, let's take any value between minus 3 and minus 2. Let's take minus 2.5. Now, minus 2.5 plus 2 will be a negative quantity and minus 2.5 plus 3 would be a positive quantity. So, negative number times a positive number will be a negative number. Let's take a value that is lesser than minus 3. Maybe let's take minus 5 for example. Minus 5 plus 2 is minus 3, that's a negative number. And minus 5 plus 3 is minus 2, which is again a negative number. So, two negatives make one positive. And therefore, any value to the left of minus 3 is going to yield a positive number, right? Now, if you have done all the steps correctly, you don't have to worry that, Anirudh, what if I had taken minus 8 or minus 7 maybe, right? That is never going to create a problem. If you have drawn all the zeros correctly, and if you are good with your basic mathematical calculations, you are never going to be making an error. All right. Now, what was the question? This expression should be greater than or equal to 0. So one thing is very clear. I know when would this expression be equal to 0. I mean, that is what we did when we found out the zeros. So what needs to be done? I need to find out those values for which this expression would be greater than 0. That means a positive number. And we have done that as well. So I know that if x is greater than or equal to negative 2, I will be getting a positive number or 0. Or if the value of x is less than or equal to minus 3, that is when I would be getting a positive number for this expression, right? So this is how we are supposed to solve whenever a quadratic inequality is given to us, right? Now, there are some quick steps that can be done which would help us to avoid taking values in all these ranges. So let's try and understand that. Let me take one more example. But in this case, we would be taking more number of polynomials. So over here, we had just 2 polynomials. Let's take maybe 3 polynomials for now. So I have got x plus 1, I have got x minus 1, and I have got x plus 3, and this thing must be less than 0. Let's say this is the next question given to me. What would be my first step? Try to remember. We would be drawing the number line. What was my second step? To plot the zeros of all the different polynomials. So over here, the 0 would be minus 1. Over here, the 0 would be plus 1. And over here, the zeros would be minus 3. So let's plot all of them. So I'll plot minus 3, I'll plot minus 1, and then I'll plot plus 1. I hope this part is clear. Now, as we can see, the number line has been divided into 4 regions. Let's start with a value that is towards the left of 1. Now, this might be a bit cumbersome, but please pay attention. Let's say I take 2. Now, after taking 2 and putting all the value, 2 in all these brackets in all these polynomials, you will see that I am getting a positive number. You can check it for yourself. If I take any value between -1 and 1, let's say I take 0. If I substitute 0 over here, I would be getting a negative number. If I take any value between -3 and -1, let's say I take -2, I would again be getting a positive number. And let's say if I take any value that is less than -3, let's say -5, I would be getting negative over here. You can check for yourself. And once you check that, you will see that a pattern is being formed. What is the pattern? That to the extreme right of my rightmost 0, I am always getting a positive number. And then there's an alternate cycle that happens. So positive, negative, positive, negative. But what's the important part? That you plot these zeros carefully and you don't make an error in terms of the order. I mean, I have had students who are making this error of writing -1 over here and -3 over here. So that is going to mess up your entire answer. So the first step and the second step are very, very important of plotting the zeros very, very carefully, right? Now, this is something that will save a lot of time in actually calculating the values. But please understand, this comes with a slight twist. We would be discussing that next. But what was the learning from this? That whenever you encounter polynomials being multiplied with each other, what you are supposed to do is, you will be plotting the zeros. To the right of the extreme right 0, you will always get a positive number and then an alternating cycle follows, right? Now, answering this question that I want my answer to be less than 0, what would be the answer? X should be less than 1 and greater than -1, or X should be lesser than -3, right? I hope this part is clear to you. Now, let's take it one step further. I mean, we will now talk about a case where this logic of ours might go for a toss. All right. Now, let's say there is a question 2 minus x, x minus 3 and x minus 5. The product of this should be greater than 0. Can you see a difference in this question from the previous ones? Let's see if you are not able to figure that out. Let's see what's going to happen. So my first step would be to plot the number line. Next step would be to plot the zeros. So 2 minus x, if I equate that to 0, the value of x becomes 2. So that is going to be my number 1 zeros. Then the value of x would be equal to 3 and the value of x would be equal to 5. So these are the 3 zeros and therefore my entire number line has been divided into 4 regions. Now, according to the logic that we have just made, what should be the answer? That to the right of 5, I should be getting a positive number and then positive, negative, positive, negative. That is what should happen. Let's check whether that is happening or not. So let's say I take 6. What would be 2 minus 6? It would be a negative number. What would be 6 minus 3? That would be a positive number. What would be 6 minus 5? That would again be a positive number. Now, negative multiplied by positive would yield a negative number, right? So, to the right of 5, I am getting negative as the answer. Now, just think, why did this happen? What was different in this question that was, not present in the previous 2 questions that we discussed? So, I hope that you were able to figure that out by now, that over here, the coefficient of x was negative. And whenever the coefficient of x is negative, the logic which we just studied goes for a toss. So now, how do we counter it? It's actually a very, very simple process. See, what needs to be done? You will be taking out negative sign common from here, right? What was the logic? That if the coefficient of x is positive, to the right of the extreme right 0, I will be getting positive and the alternate cycle begins. So we will try and write this expression in that format. So the coefficient of x is positive in this case, the coefficient of x is positive in this case. So the only problem was with 2 minus x. So what I'll do is, just a minute. So this 2 minus x, I will rewrite it as x minus 2 followed by a negative sign outside, then x minus 3 and then x minus 5, and this thing should be greater than 0. Now, I will be taking out this negative sign and sending it to the right hand side. But remember, we just discussed that there's a difference between an equation and an inequation. So while taking this negative side to the other side, I will have to change this sign of inequality. So this will be x minus 2, x minus 3, x minus 5, and this thing should be less than 0. Alright, now all the coefficients of x are positive. So the logic which we made will be holding true over here. So let's plot. My roots would be, my zeros would be 2, 3 and 5. To the right of 5, I will be having positive, negative, positive, negative, and that alternate cycle will keep on happening. Now, what did we want? We wanted our answer to be less than 0. So that means a negative number. So therefore, x must be less than 5 and greater than 3, or x must be less than 2. So that would be the answer to this particular question. So whenever you encounter such a case where one of the coefficients of x is negative, make sure that you make it positive by taking out negative sign common and sending it to the other side, but also ensure that you are changing the sign of inequality if multiplying or dividing by a negative number on both the sides. Alright. There can be another exception to this. So let's discuss that, and that would be the last exception. Post that, we would go back to the question that was asked to you for this particular week. Alright, so let's say the question is x plus 1, x plus 2 and x plus 3, the whole square is greater than 0. Let's say this is the question. What is my first step? Draw the number line and plot the zeros. Now what would be the zeros? Minus 3, minus 2 and minus 1. Now we will be plugging in values and we'll be checking whether we are getting positive or negative. So what was the logic? If the coefficient of x is positive, we would see that to the right of the rightmost 0, I am getting positive and there's an alternate cycle being followed after that. So let's check. Let's take a value between minus 1, greater than minus 1. So let's take 0. So 0 plus 1 positive, positive, positive. Over here, I'll get a positive number. Let's take a value between minus 1 and minus 2. Let's say minus 1.5. Minus 1.5 plus 1 would be a negative number. Minus 1.5 plus 2 would be positive. Minus 1.5 plus 3 would also be positive. Two positives and one negative will make a negative. So the logic is holding true. There, we started with positive and then there's a negative sign. Alright, let's take a value between minus 2 and minus 3, minus 2.5. So minus 2.5 plus 1 would be negative. Minus 2.5 plus 2 would be negative. And minus 2.5 plus 3 would be positive. Two negatives and one positive will make one positive. The logic is holding true. So maybe this was not an exception. Let's see. Let's take a value lesser than minus 3. Let's go for minus 4. Minus 4 plus 1 would be negative. Minus 4 plus 2 would again be negative. Minus 4 plus 3 is negative, but there is a square over here. Now since there is a square over there, square of a negative number would be a positive number. So this will again be positive. So two negatives and one positive will again make a positive. And there's a discrepancy that we were looking for, that we were actually hoping for. So positive, negative, positive and positive. Now think, why did this happen? Why did this happen at this juncture, at this turning point? Why didn't the sign turn? Why didn't the sign change over here? Because look at this. This was minus 3, right? And this was the 0 of which polynomial? This was the 0 of this particular polynomial, which has a square to it. Now, you do the square of any number, it's always going to be positive. So, technically, this expression, this polynomial is not helping me change the sign. is not helping me turn the graph, and that is why we did not see positive changing to negative over here. Right? So now, how do we tackle this question? How do we bring it to that plane where, we can go by that logic of starting with positive, negative, positive, negative? How can we do that? It's actually a very simple thing. Let's look at it. So now the question was x plus 1 times x plus 2 times a positive number is greater than 0. I am not writing x plus 3 the whole square over here. Understand this. X plus 3 the whole square is always going to be a positive number. I mean, it could be 0 as well. We are obviously going to consider that case, but it's always going to be a non-negative number. And since I know for a fact that this is never going to be negative, what I am doing is I would be taking to the right hand side. And therefore 0 divided by x plus 3 whole square would still be 0, and that is coming with a side note that the value of x is not assumed to be minus 3. Right? We will have to keep that thing in mind. So now my question changes to x plus 1 times x plus 2 is greater than 0. I have taken this to the other side, and I don't have to worry about the sign of inequality because that is only going to change when we multiply with a negative number. I know for a fact that this is never going to be negative since there is square to it. All right. Now, this is my question. All the coefficients of x are positive. There are no powers over here. Therefore, I can go back to my logic. This is minus 2, minus 1, over here positive, over here negative, over here positive. So what's my answer? My answer would be that x should be greater than minus 1 or x should be less than minus 2. I hope this part is clear to you. Now, if you have understood this concept, the question that was given to us for the day, for the week, is actually a very simple one. What are we supposed to do? X plus 2 times x plus 3 over x minus 2 must be greater than equal to 0. But what I have seen most people do is they forget reading the question. The question is, how many of the integers that satisfy the below inequality are less than 5? So I have to solve this, and I also have to take into account the constraint that the value of the the value of the variable x should be less than 5. All right. So now, how do we tackle this? Can I take this x minus 2 on the other hand on the right hand side? I hope you know that the answer is no. Why is that? Because this is not a positive number. I mean, this could be a positive number, this could be a negative number, and since I don't know the nature of x minus 2, therefore I am not allowed to take it to the other side. All right. So now, how do we tackle this? Let's see. If this is not a perfect square, let's make it a perfect square. What I'll do is x plus 2 and x plus 3, which were part of my numerator, I'll keep that as it is. Now what I'll do is I'll multiply x minus 2 in both the numerator and the denominator, and this thing must be greater than equal to 0. All right. Now, x minus 2 into x minus 2 is what? X minus 2 the whole square. And x minus 2 the whole square is obviously going to be a positive number. So therefore, if I take it on the other side, I don't have to worry about this sign of inequality. So now my question changes to x plus 2 times x plus 3 times x minus 2 must be greater than equal to 0. But we have to be very cautious. Why is that? Because in the denominator there was x minus 2. So I am pretty sure that if this question is asked, we will have to take into account the value of x as 2 as well. I mean, this could be the make or break thing for us, right? So if we are doing this, we will have to assume that the value of x cannot be equal to 2, because if the value of x is equal to 2, my denominator would become 0, and that is mathematically not possible. All right, coming back to the question. So x plus 2 into x plus 3 into x minus 2 must be greater than equal to 0. Are all the rules of our logic being followed? Yes, there are no higher powers, and all the coefficients of x are positive. So my first step would be what? To draw the number line. Then plot the zeros. So what would be the zeros? I have minus 3, I have minus 2, and I have plus 2. What would be the next step? to the right of the rightmost 0, I will be putting a positive sign, negative sign, positive sign, and negative sign. Now, x should be greater than equal to 2. In this particular case, please understand that the question was talking about greater than equal to 0. So therefore, if I try to plot this, what would I get? X must be greater than equal to 2. What else? X should be less than equal to minus 2 and greater than equal to minus 3. Right? Because these two are the only ranges where this entire expression is staying positive. All right. So now we will have to keep that in mind. Now, what's the question? How many of the integers that satisfy the below inequality are less than 5? Right. So if x is greater than equal to 2, what are the possibilities? X could be equal to 2, it could be equal to 3, it could be equal to 4, it could be equal to 5, it could be equal to 6, and so on. If I talk about this, x should be less than minus 2 and less than equal to minus 2 and greater than equal to minus 3. So therefore, the only possibilities are what? Minus 2 and minus 3, because these are the only integers between minus 2 and minus 3, including them, right? So if I look at this, the answer seems to be infinite. But what's the condition? My integer must be less than 5. So what are the integers less than 5? I have got 4, I have got 3, I have got 2, I have got minus 2, and I have got minus 3, right? So it seems like that 5 would be the correct answer, but I hope you don't forget this logic that the value of x cannot be equal to 2, so I will have to exclude this as well. So therefore, what are the acceptable values of x? X could be 3, x could be 4, x could be minus 2, and x could be minus 3. These are the only 4 values of x which would be acceptable, and therefore option D should be the correct answer to this question. I hope you were able to understand this entire concept, this particular question. If you like this video, please make sure to like this and subscribe to our channel for more such content. This is Anirudh Murarka signing off.